what does error handling mean specifically? Well, errors in general are quite common when it comes to programming. So I don't think there is a person in the world who is perfect and never makes any errors. I actually wanted to start this off by philosophizing a bit, so I read from the English Wikipedia what it says about errors, and it's not that Wikipedia page is not very programming specific. It just says that an error, the word comes from the Latin word error, which means wandering. It's an action that is inaccurate or incorrect. In some cases, error, it means the same as a mistake. In statistics, an error means the difference between the value which was calculated and the value which was correct. And an error could result in a failure or in a deviation from the intended performance or behavior. And in terms of programming, maybe this first line, this action which is inaccurate or incorrect, or maybe even a mistake in some cases, or maybe this failure or deviation from intended performance or deviation from intended behavior. These are all the sorts of errors that we probably mean when we are talking about programming related errors. So let's just take a quick look at how we make errors in practice. So let's start with looking at programming errors in practice, something that you may, well, probably most of you have already seen. So to bring up the programming environment here once again. Okay, so let's say what is the typical way of making errors when we are first learning to program? Well, let's say we only have a very short program code and we type something like this. So print hello world. This you can see is faulty because commands in the Python programming language start with lowercase letters, and I have a capital P here, so this should not work. Just as a side note, there are some programming languages where there is no difference between lowercase and uppercase, but in Python there is a difference. So Python is a case sensitive language. So anyway, so let's say I have this line of code and I have made an error in just typing this code. So if I now try to run it, I will get some sort of response from this interpreter here, meaning we get something called first of all here saying traceback, most recent call last, and then a few lines below it we get a name error. So what it actually means here is that the interpreter has tried to read this program code, but it doesn't know what name we are referring to with this print. Notice that it does give an error, so it does try to run this piece of code, but it fails rather than just refusing to run this program code. So for example, if I was to make an indentation here where it doesn't belong, remember how all these indentations mark those code blocks which are associated to if-else statements and functions and certain other program blocks. So for example, those and loops and opening a file using the with statement and so forth and so forth. So if I was to do this, which is an illegal language construct in Python, and then I try to run this, I should see the other type of error, which is a plain syntax error. So here, what the environment is telling me is that I have clearly written this wrong. This cannot be, and the interpreter is refusing to even start running the code. So this is one type. These are two different types of errors. The syntax error is just because I have not followed how I'm supposed to write Python code, but if I just but whereas this traceback or name error here on the right means I have just used some name which the interpreter doesn't understand. So again, two different types of errors there. So even though this error message in red may seem a bit cryptic at first, it's actually pretty informative. So it's telling us, first of all, what is the line of code where the error happened. So the first line after this traceback line is where did this error occur? And it says it's in file something.py. So that's our source code file. Okay, as we are writing everything in the we have been writing everything into the same source code file anyway. We probably can just ignore this file name. But then it says it's an error on line 1. So that basically means the first line of program code. So if I just show you real quick this code editor, we can see that, well, as there is only one line of code here, this must be line 1. It's not actually the physically line 1, however, as this is not at the beginning of the file. So actually this line here is physically line number 1. And you can see the line count here at the bottom right of the editor window. You can see there is a ln is short for line, and where our faulty print statement is actually physically on line 5. But the other thing to remember here is that because the Python interpreter also skips the empty lines, this is the first proper line of code. This makes finding out the where the error exactly is a bit more difficult, but in general, the line count gives you an idea of where the error happened regardless. So just as a little heads up about that line count there. But generally, it does the error message does point to the way of where the error happened. What may be even better in terms of trying to resolve this error is then it will print the actual line, the actual command that we tried to use right here, which was faulty. And here, this is probably, if not the most important piece of information. It's probably the second most important piece of information regarding this error. Maybe the most important line is the last one here. So what it's saying in here, name error, name print is not defined, means the interpreter is telling us which word it doesn't recognize. And in this case, it's print with a capital P. So here, how we would interpret this error message is what we start to do is we start to read from the bottom. Okay, we have a name error, print is not defined, and it's on this line saying print hello world, which should be on what was then line 3. I think I moved it now to line. So it's on this physical line 5 here. So we should locate this name print here based on this information. So it's the name print, which is not defined, and it's on line 5 and in this statement. So now we could see that indeed this command is misspelled. We should spell it with a lowercase p, and this is generally how we would use this error message on the in the interpreter to try to fix the mistakes in our code. And of course, running them afterwards and fixing the mistakes we did here. Here it was more or less obvious, and now we can see we have got it working. So more than just how we can use this error message to figure out what happened, what was the error. Also, something to note: this interpreter, even if it doesn't point to the exact cause of the problem, it will give you a pretty good idea of what you're doing wrong. And specifically, understand here that the interpreter can show you where the code is doing stuff that it shouldn't, where you have typed code that doesn't work. But the Python interpreter just doesn't know how to recover from this error. And this is a good thing to keep in mind, because this is more or less the underlying idea behind error handling in the first place. So keeping in mind, the interpreter can point to the cause of the problem, but it just doesn't know what to do after an error has occurred. So that's why it gives an error message and it stops the execution of the program. So this is basically where we would use something called error handling. So it turns out you can use some coding techniques called error handling techniques to help the interpreter by constructing a recovery plan for how to get out of this error state. So basically what you can do is, if something unexpected happens, you can program an escape route from the state where the program or your user does something unexpected. As an example of where errors could happen, one of the most error-prone things to do is ask for user input. Because we can't really predict what a user is going to be typing on the keyboard. If users are given if users are given a free choice to type anything on the keyboard, then they will probably type unexpected things and occasionally get the input wrong. So we can't really rely on user input that much. So as an example, if we were to make a program where we're trying to make some calculations and we ask the user to type in some numbers, there is no actual guarantee that the user will actually type in numbers only, because a keyboard consists of both letters and numbers, and there's nothing preventing a human user from typing something random in. That's basically because users are unpredictable, and users sometimes make mistakes. Like the program, the user is a human. So we should have some kind of mechanism to anticipate these user mistakes. And what we really want to do is want to have a way from to recover from these mistakes. So that's all what error handling is all about. One way to try to mitigate these errors, user errors, using methods we have already covered on this course, is through input validation. So what we could do is we could check some properties of the user input before we are using them for any purpose. So, for example, let's consider a simple calculator program. So we go here and start with this calculator demo. So let's build a calculator that divides. Actually, let's say that first of all asks for two numbers, and secondly, the calculator divides the first. Divides the first number with the second number. So we ask for two numbers. The first is going to be what is called the dividend, and the second one is going to be the divider. So this is going to be a calculator that knows how to do one mathematical operation, and that mathematical operation is the division. So how this might work. So let's first ask for the first number. We make an input statement to ask for user input here. Give the first number. Then we do the same with the second number. Give the second number here. So this should just ask for user input right now. And what we want to do with this input, we want to take the dividend and divide it with the divider. So divide this with the second number. So, and I'm going to be a bit lazy. I'm just going to type out the result of this computation inside one print command. So that's going to be dv. And actually, I'm going to print out the numbers as well. So let's do something like this. So dividend, the slash symbol to signify that this is a division, divider, and what this calculation equals, and then we take because this is user input, we have to transform this into a number using int, and we have to do the same for divider, the second number as well. Okay, and just to make this work a bit better, yep, let's put this whole print statement on 2 lines because it's a bit long. So now you can actually see the whole line of code in a bit more easily. Okay, let's try this out. So just run this. What is 10 divided by 2? 10 divided by 2 is exactly 5.0. Okay, cool. Let's try a few more numbers, maybe 15 divided by 2, that's 7.5. And 147 divided by 3 is exactly 49. Okay, great. So we have this calculator that works. Well, it works sort of. I mean, so far I have tried it with a few numbers. So 147 and 3, 15 and 2, 10 and 2. All of these are legal inputs because well, I know that the program is expecting me to input numbers, which makes sense. What if I try an illegal input? So what if I try to divide 100 with 0? Now, as you might know, you can, because that's an illegal operation. So what happens when I try to run this code? We get an error. Specifically, what we get is a 0 division error, and then it points out helpfully that this is a division by 0 and it should not work. Okay, so how could we engineer our way around this problem? So in these text-based programs or programs with specific type of numeric user input, usually it's enough to test the user inputs and to check that they are within expected limits. So here the expected limit is that the second number, this divider, first number, that's the second number. So the second number cannot be a 0. So what input validation would be in this case, we can ask for input here, no problem. But then when we have to do the actual calculation, which happens here, then we would probably need to check that this second number is in fact not a 0. So we would say something like if the divider is not equal to 0. If and only if this condition holds, then we do this calculation. So we're only allowed to do this division if the divider is not 0. And of course, notice that again, because input is text before we try to convert it to a number here, we're using int. So I'm therefore surrounding this 0 symbol here with the quotation marks, because the 0 is going, the potential 0 that we see, or the input that we get from input is text. So, and text needs to have the quotation marks around it. Otherwise, this comparison would not work. So then we would be comparing, if I left these quotation marks out, we would be comparing this numeric 0 against text, which is coming from input, and those types do not match. So this check would not work. So we better leave those quotation marks in. And this sort of already works. If we have an if statement there, we can also have an else here, saying what goes wrong if something goes wrong in this calculation. And we could put in a helpful error message of our own, or a helpful piece of information inside another print to notify the user that you cannot divide by 0. Okay, let's see how this works. So let's start with some legal inputs again. So let's try to divide 15 by 3. That's 5. That works. What if we want to divide 3 by 0? Now we get this our own error message, information, informative message here, cannot divide by 0, and the program does not crash anymore. You don't see this red error message because we took this possible error state into account here in our if else construct. So we checked if this possible error state division by 0 could happen, and we took it into account. And this is an example of how to do input validation with your or how to validate your inputs for potential error states. And the else demonstrates basically how to get out of the error state. So if we were to use the result of this calculation later on, then we would probably have to take that into account in the else block here. But now that we're not doing anything more fancy with this calculation here, we can just get by just printing a message on the screen. This approach takes into account one error state, which is if we are trying to divide by 0. But of course, this only accounts for that one error state. And it turns out there are multiple things that could go wrong in this code or when running this program. So let's, for instance, say, so again, trying to divide something by 0, we have taken this into account, but what if we were trying to do something even more obscure? So division by 0 is already a bit odd, but what if we wanted to divide, let's say, 2 by a potato? This will give us another error. This is not a division by 0 error. This is a value error. So now what it's saying is this integer conversion. So trying to convert potato to an integer number has failed because, well, a potato is not a number, because a potato is a vegetable, obviously. So as you can see, while we did take into account this one error state here, this still doesn't prevent the user, me, from typing in random things into the command prompt here or into the input prompt here. So what to do with this? Well, we could try to take this illegal input, this other illegal input than just 0 into account as well. Let's see how to do that. So we could try to check if these numbers, dividend and divider, are actually numbers or not. So we might check if the dividend is numeric. This I think we covered on the previous week or so, on one of the previous weeks. So if we attach this dot is numeric to any piece of string, it will tell us if all the content of that piece of string, piece of text is in fact all numbers. And of course, because we want to do this for both the dividend and the divider, both the first number and the second number, I can join this. I can do the same with divider and join it with this AND keyword here. So if the dividend is numeric and the divider is numeric, then we can proceed with doing the calculation right here. So then we move this whole existing program inside this this if else block, and if we want to, we can even print another informative message here inside another else block. So now this if statement here is paired with this else block that I'm just going to be typing in, and this inner if else is paired together. So this if is paired with this else, and that else is paired with this if. So here we might say that something like you must use numbers only. Okay, let's see if this works. Well, it should. We have pretty much taken into account all the possible inputs that a user could type into this command prompt. So let's try with something that's legal again. So let's say 80 divided by 6, that's 3. Okay, it works. Let's try the 0 case, so maybe 80 divided by 0. Cannot divide by 0, but we don't get an error message either. What about those ridiculous inputs that we could use? So let's say we wanted to divide a pizza into 6 slices. Again, this might make sense in a natural language. We might actually divide a pizza into 6 slices, but of course, because this is a computer program, then we have to type in these inputs as numbers, so they must be numeric. Let's try this out. Okay, now it says you must use numbers only. Let's try this in detail. So let's try to divide this pizza into 6 different portions. Okay, doesn't work. And what about the other way around? Can we divide 10 by that by a potato? No, we can't, and still we do not get an error message. So we have pretty much handled everything that could possibly go wrong here. So that's all well and good. So this input validation, as you can see, it works, and it has a lot of different applications. There are a lot of times when you might be doing this because it makes sense to try to validate the input a little bit. As you can see, for this purpose, it does seem a bit laborious. So we have made this calculator program, or this division program, which started out as only 3 lines of code, and now it's about 10 lines of code. So it seems really laborious. Another thing we have done here is as we are writing more and more code to handle all of these small little problems. Well, first of all, there is quite a lot of code for what is quite a small problem. And what's even worse is that once you add more code, it's possible that you introduce more errors, more states that this program could go into, and possibly more states that we would need to try to anticipate and build those error recovery strategies for. So, for example, how we made this more complicated. What if we test this previous example with some decimal numbers instead of integer numbers? That's something we didn't try yet. So let's do that. So the program does not change, only the inputs that I'm trying. So let's try to do 10.0 and divide it with 2.0. And this should work. These are legal numbers as such. As you know, the interpreter will happily calculate the division like this, but still we got this printout here, which came from this second else, which basically just checked if these inputs, the dividend and divider, match this is numeric condition. So the problem here is that is numeric works only for integer inputs. So this works only if everything is a number, but it does fail with floating point numbers. There is another thing to take into account in the implementation of our division, where we actually did the division. So floating point numbers would not necessarily work. Well, they might work, they might not work correctly. So basically here on this line where we did this actual division, that's the division operator. So this is where we actually divide these numbers. As you can see, we convert these inputs into integer numbers and not floating point numbers anyway. So even if this program worked, we wouldn't it would not necessarily give us the correct answers, as this integer division might screw up some of the decimal values that we input there. So that's another state of not necessarily error, but another mistake we have now put into this little piece of program code. So yeah, as this, even though this input validation does make a lot of sense, it doesn't take into account all the different types of errors there could be. We could still trigger an error message somehow. Maybe there is another error in the program code, or maybe the program just stops unexpectedly. So if you remember, one of the ways to stop a program from running is during the program's lifecycle. If you hit the keyboard button combination Control and C, this will force the programs to stop, and then you get another error message as well. So it is possible to trigger an error message regardless. Just to again remind you how that works. So if I type in some input but then press Control and C, we get an error message, not because the program crashed, but because I pressed the keyboard interrupt keys, Control and C, to cause this error state. So this is another type of error that happened. It didn't occur naturally. I had to force it to happen, but it is possible that errors still happen. So again, input validation is important, but it does not work for all the kinds of errors that you might come across. So if we try to remember back to this example of the error message and how it should be interpreted. So it said in one of the previous slides that the problem isn't that the interpreter doesn't understand what's going wrong. And it's quite the opposite. It knows exactly where this code went wrong and what you typed incorrectly. What the interpreter is actually saying, it doesn't know how to continue from here. So the interpreter is pointing to the cause of the problem. It just doesn't know how to resume from here. And this is basically where error handling would come in. So we might do something called error handling, and the way to do error handling in Python is through try except blocks. So try except blocks are program blocks where you can try to anticipate errors and make exceptions when errors occur. So this is basically the way you as the programmer can help the interpreter by building these ways to recover from errors in the case the program or the user does something unexpected. So this kind of a try except program block is a structure for catching errors and recovering from them. So in the try block, we put the code that we attempt to run, and then if an error occurs, when executing whatever code is inside the try block, then the interpreter stops and moves on to the except block instead. As an example of how this might work, let's do something that makes that resembles this calculator program somewhat. So let's do something like try. We try to ask for input. Let's ask for the user to type in a number, and then we also try to convert this input into an integer number. And then we also try, we're still in this within this try block, so everything we're doing here is we are trying to do something. Let's just print out what this number was. And to go along with the to go next to this try block, we need an except. So this is what gets run if something goes wrong within this try block. So then we would guess that whatever goes wrong here has to do with this conversion from this input to an integer. So probably the user did not write a proper number. So let's test to see how this works. So if we give a number such as 7, then this try block will continue to the end. So these 3 lines of code will work. So first we ask we give this input prompt here. We try to convert whatever the input is into an integer number, and then we print the result of that conversion. And as you can see, this all worked. What about if we try to input something that isn't a number? Well, then usually if this integer conversion here would not work, and you would get the error message. But as we have this try except error handling structure here, once this integer conversion fails, we jump into this except code block here, and instead it prints this message that we put here in the except block. So this except block or exception block covers everything that could possibly go wrong in the program code. And the reason it's called except is in Python, these errors are called exceptions. And the actual technical terminology is that when an error in the program's execution happens, the program throws an exception, and then the except block catches that exception. So it's think of the exceptions as balls that you might if you have ever played baseball, you throw an exception and then you catch an exception. So you have a pitcher and a catcher. Depending on the type of the error, we have different exceptions. So if you think about that division problem in the previous example, if we tried to use illegal inputs like text in place of numbers, then the program would throw a value error. And if you tried to divide by 0, you would get a 0 division error. So if we go to see how these different errors work in practice, let's consider the division program once more. Okay. So let's once more ask for input. So dividend is going to be the first number. Give the first number. And the divider is going to be the second number. And then what we can do is to try to make the calculation here. And notice I'm not putting everything inside the try except blocks. I should probably name this divider, not proper, or I should probably spell divider properly. So even though this user input can fail, it's not uncommon, but it's just not what we expect to do. So if the user input fails, then there is something larger wrong with your computer. So the only thing that can fail is this actual calculation, not the user input. And as I am not trying to convert this user input into a number yet, it doesn't matter. So I'm only putting this actual calculation within this try block. Again, I'm going to be a bit lazy and just put everything here. So we want the dividend divided with the divider, and that equals the numeric version of the dividend divided with the numeric version of the divider. There we are. And then we can make an exception for some errors and print out a message saying that something went wrong. Okay, let's see if it works. So for example, let's do 14 divided by 7. Okay. yeah, something went wrong, and what that something is I accidentally misspelled dividend here. So let's so notice it doesn't matter if it's a programming error in me naming these variables incorrectly, or if it's the user giving this try will and that's why it just says it's just a general except block. It catches all errors, and that's why I named this text just generally something went wrong, but we don't necessarily know what went wrong. Okay, let's try with dividend spelled correctly and do this again. Okay, let's try with these same numbers once again. So 14 divided by 7, that's 2. Okay. Some legal inputs work. So if we try to force this program into some error state, for example, by using illegal inputs, then we can trigger this error state. Notice, however, that it doesn't matter here what the error is. So if it's an illegal input or division by 0, you always just end up with this same procedure here. So this except line will throw an exception or will catch the exception for anything that went wrong. And now that's where these different exceptions come into play. So if we know that we might be expecting or we should expect a error in this division where the user might type in a 0 as the divider, then we might be expecting a 0 division error. And in this case, we might say a more specific message here. So cannot divide by 0. So now, if we try to do that, 14 divided by 0, if we try to divide by 0, we get this cannot divide by 0. But if we tried to do something else, now have some illegal input here, then we get another error message here. So in this case, it's a value error. That's because these errors are different from each other, and they can help you plan this try except structure. So in this case, if I change this exception here to a value error, and then we printed a message saying you must use numbers, because that's what is going wrong. We are not typing in numbers to the prompt. And then try this again. And now if we again have the number 14, and we try to divide it with a potato, we are catching this value error. If we go back to the to trying to divide with 0, however, now we are back with the 0 division error, because now this value error, this divide by 0 case is not caught with the value error. So for this reason, you can in fact stack these different exception types to distinguish what exactly went wrong with the program execution, and how to efficiently back away from the problem. So the different error types help you to recover, to plan how to recover from different types of errors. The general exception block, so just a plain except with no error type specified, will catch all possible other errors regardless of their type. This generic exception block is an easy way to deal with unexpected errors, but it is then harder to know what actually went wrong. It's harder to recover because you don't know what specifically went wrong in the execution of the program. So if we complete this example using this idea, so we are here trying to do this division, and we have accounted for a value error. We can also account for the zero division error right now. And we can have another informative message here explaining that we cannot divide by zero. And finally, if we could list these different error types here as much as we like, but the one we might want to end with is the generic except block. So if nothing that we specified previously, if it's not a value error and it's not a zero division error, we can't think of what it might be, then we might just say, look at a situation where something went wrong, but you do not know why. Or well, we might be able to find out, but it's a bit more laborious to do that. Okay, let's try this out now. So legal inputs like 14 and 7 should work. Trying to divide by 0 should give us the cannot divide by 0 error message here, or well, informative message here. And using illegal inputs, such as trying to divide 14 by a potato, will just give us this you must use numbers. As to how to trigger this final exception block, this is a bit harder to do, but I might try to do that by moving these inputs here, so I have a bit more time. Don't worry about why it wasn't there previously and why it is here now, but let's try to start the program, ask for inputs, and then hit Control-C. So as you remember, Control-C, the stop this program right now, also triggers an exception. But now, as we have a try except, a generic except block here, which catches all the possible error codes, then we don't see the Control-C error message here anymore. We just see something went wrong, but we don't know why. This should say something went wrong. But anyway, so here the point is, if we have these expected error types here and then something that we might not expect, it's not uncommon for something unexpected to come by, something that you didn't plan for, even given these exception types. It's good to have something as a backup, and that's what this plain except block is for. Of course, you can do the same by just leaving out these specific errors and just have one try and one except block. But here again, it may be harder to figure out what is exactly going wrong, because your logic here if something goes wrong, just go to this exception block here. It might be harder for you to figure out afterwards what exactly went wrong. So that's why these specific error states, specific error messages exist. And the exception block, the generic except block, should only be used for truly unaccountable situations. Of course, there's a plethora of different error types, so it might not make sense to list them all here, but maybe just the one or two that you might reasonably expect, such as for this calculator to have a divided by zero error or a value error if there are illegal inputs. So all of this makes sense in this calculator context. Finally, there is a program block called finally. Now, the finally program block is an additional code block that works similarly to the try and except blocks, except it's meant for a slightly different use. So while try and except work on their own, there is also a third part to this try except structure, which is try finally. So the or try except finally. Finally block is used not for error recovery, but is instead for gracefully bringing the program to a stop if something fatal occurs. So the idea is that a finally is there because sometimes you have to make sure that when a program stops because of an error, you have some things that you really want to do regardless of if the program exited after completing everything in the try block, or if it hit an error and went to the exception block. So finally, something that if you attach it to a try except structure, then whatever is in finally will always be executed no matter what happens. So this is more of a academic exercise at this point, because in the first programming course there isn't really much use cases for the finally block. So this may seem a bit odd at first even, but it does become more useful when you have more programming experience. Just for now, just remember that such a structure exists. As an example of where you could use this, in previous lessons we talked about files, how to open and close files, and that we need to remember to close a file after opening it. So let's say we had a program that opened a file to read or write from it, and then we had the program crash in the middle of reading or writing to this file. And that, if left untreated, would leave a file handle open, unless we had a finally block at the end of our code, which ensured that the program did some cleanup and closed the file handle. So that's more of a use case of where you might see a finally, but the next few examples should show in practice how the try finally structure works. So if we get rid of this previous example here and move it away from the screen, here we are. So first of all, let's start with some try block where there is something that could go wrong. And just for the sake of this demonstration, let's do something that is sure to fail. So this is an obvious error, just to show that how this try finally example would work. So here's a try block inside which you can have some code, and I have written some code which is guaranteed to fail because division by 0 is illegal. You cannot do that, so the computer will, and the Python interpreter will throw an exception at this point. So if I pair this try with a finally, I can then say this line at the end of the program is going to be printed no matter what. So if I now run this, so remember this calculation inside this try block, this is going to fail and it is going to throw an error. And we're waiting for this try block to catch the error and this finally to print this last line, this comment that this line is going to be printed at the end of the program, no matter what happened. So as you can see, what happened here is that inside this try block there was a there is this faulty line, and you can see the error message here. So you can, the first intuitive thing is to think, okay, so the try block don't actually catch the error. Well, that's not true. It did, because remember the try block is not for recovering from the error. So the try does not emit this error message. It's the except block that does it. So used like this, this error message will still come up. And notice this print here. So in fact, this line right here that's going to be printed at the end of the program no matter what, it shows up here just before the error message comes up and the program stops. So basically the takeaway here is that if you use this finally, then whatever is inside the finally will happen just before the program stops, regardless of if the program stops because of an error or because the program stops because it reaches the end of the program. So as you can see here, now this program stops because there was this error message. If we wanted, we could supplement this try finally with an except block here, and here we can catch the exception that happens. So now as this as the code inside try fails, we take it into account in except and print something else than the error message, and the finally portion here guarantees that whatever is inside it will get executed at the end of the program. So if I run this code now, instead of throwing the error, it will say there was an error, but that's because that's the line of code that was in this within this except block. And then at the end of the program, just before the program ends, we get this last line that the finally guarantees that is going to be printed on the screen or executed at the end of the program. So that's basically what the finally does, and how this finally code block ensures that whatever is inside it will be performed or executed, regardless of if there was any error in this within this block or not. So if there was just something that is not doomed to fail. Let's just put an empty print statement there and see what happens. Here you can see an empty line, and even when there was no error, this finally block is executed here. So the finally really happens at the end of the program, no matter what, and that is what's the point of the finally. So if we have to make sure that something happens, finally is the tool to do that. Okay, I believe this is all we had material for today. So once again, at this point, it is time to switch off the recording.